Hi, welcome to another video on trigonometry, and in this video we're going to be looking at past paper questions on the reduction formula. Our first question states, determine without using a calculator the value of the following trig expressions. Before we go into the question, on my right you will notice we have the cast diagram reminding us that in quadrant 1 all are positive. In quadrant 2, only sine is positive. In quadrant 3, tan is positive. And in quadrant 4, cos is positive. So we're going to use the diagram. It's going to be quite handy as we go through this problem. So the question states sine 2x cos of negative x. So remember that the negative angle, we can either say 360 minus x, which represents the fourth quadrant. And remember, cos in the fourth quadrant will be positive. We carry on to read cos 2x, and then we have sine of 360 minus x, which once again is the fourth quadrant, and sine is negative. So simplifying, we have cos of minus x in the fourth quadrant being positive, and we have sine of 360 minus x in the fourth quadrant. Using the reduction formula, we change that to minus sine x. We had sine of 180 plus x. Remember, sine of 180 plus x is your third quadrant, and sine is negative. So using our reduction formula, we change sine of 180 plus x to negative sine x. Now, if we looked at the top, you got sine, cos 2x, and you got a minus sine x. So what we're going to do next, as you can see, using our compound angle formula, we get sine of 2x cos x plus cos of 2x and minus sine x. So we got sine, cos, sine. So we change that to sine, bring down your first angle, which is 2x, and bring down your second angle, which is x. And remember, a positive times a negative will be negative, so we bring down a negative. So we end up with sine 2x minus x all over sine minus sine x. Simplifying that, we get 2x minus x giving you sine x. And sine x divided by sine x is 1. And because of the negative, we will get negative 1. So the only one that is a little confusing here is the expansion to be able to see sine cos, cos sine. Is a compound angle formula, and we simplify it to sine. And remember what I said, a positive times a negative will give you a negative, and with sine, our sign remains the same. Okay, we're looking at our second question, which says simplify to a single term, and we got sine of 540 minus x. That's our first expression. So remember, if we have anything above 360, we can just subtract the 360 there, and we end up with sine, and 540 minus 360 is 180 minus x. The second one we see, we have a sine of minus x. Now remember, sine of negative x, that's our fourth quadrant, and that will change to negative sine x. Or you can add your 360 and make it 360 minus x, which means your fourth quadrant. Then we got a negative sign, and then we have cos of 180 minus x. Now 180 minus x is your second quadrant, and cos in your second quadrant is negative. So we're going to end up with a minus cos x. And then we got a 90 plus x, which means we are in the second quadrant, and sine is positive in the second quadrant, but 90 plus x is our co-ratio, complementary ratio, so sine will have to change to cos x. Simplifying that, we know 180 minus x is in your second quadrant, put down 2 there, and in the second quadrant sine is positive. And then we got a negative sine x, which I'm going to bring down for now, and a negative times a negative is positive. Cos times cos is cos squared x. Okay, then we have a positive times a negative will give us a negative. Sine times sine is sine squared plus cos squared x. Now let's rewrite that as cos squared x minus sine squared x. And this is an expansion from your double angle, and that is actually equal to cos 2x, using my double angle formula backwards. Looking at the next question, determine the value of the following trig expression. So we start off with tan of 180 minus theta. Now that 180 minus theta is in our second quadrant. And we know tan is negative in our second quadrant. So we're using reduction formula once again. Then we have sine of 90 plus theta. Now 90 plus theta is in our second quadrant. Sine is positive. But 90 plus is a co-ratio. So that will change to cos theta. If we look at the bottom, we got cos of 300. Now using reduction formula, 300 can be written as 360 minus 60. And 360 minus 60 is in your fourth quadrant. Your 300 is in your fourth quadrant. And cos is positive. So using the reduction formula, that will change to cos 60 times. Whenever we have theta minus 360, that's a negative angle. So we add 360 to cancel the effect off. And we end up with sine theta. Now, expanding this, whenever you see tan, remember we have a formula that tan is actually equal to sine theta over cos theta. So we have changed tan, which you can see, to sine over cos, times, we're going to bring down our cos theta, and let's put that as over 1 as a fraction. And in the bottom we got cos 60, which is a special angle. You can use your calculator if you want to verify. Cos 60 is half. And then we got sine theta. So on the top, the cos's will cancel off. And we left with minus sine theta over 1, which is minus sine theta. And in the bottom, we got half over sine theta. Sine thetas will divide into each other. And we're left with negative 1. We can say there's a 1 in front over half. And minus 1 over half, you can use your calculator once again to verify. You got to invert and multiply, and that will give you a negative 2. Looking at our next question, it says, write without using a calculator. Simplify the following expression to one trig ratio. So we're going to start. So if we look at the question, the first one is sine 140. Once again, we're going to use our reduction formula. And remember, 140 is in the second quadrant. We can say 180 minus theta, and in this case, 180 minus 40. So, 180 minus 40 is in the second quadrant. Remember, sine is positive. That will change to sine 40 degrees. Then we go to the next one, 360 minus x, sine of 360 minus x. Remember, that's your fourth quadrant. And in the fourth quadrant, sine is negative. Come to the bottom. Now you'll notice the angle on the top is 40 and we got 50 in the bottom. So using our complementary angles, the complement of 50, remember the complement of 50 is 40. So we can change that to 40. Condition we change cos to sine. So the complement of cos is sine and the complement of 50 is 40 degrees. And then we got tan of minus x, which is your fourth quadrant. You can say 360 minus x, taking you to fourth quadrant. And tan is negative. So we have the sine 40 and the sine 40 dividing into each other, which will give you your 1. And then remember what I said, whenever you see tan, we can change it to sine x over cos x. And there is a negative there. So our negatives divided by negative is positive, and we end up with sine x times the inverse, which is cos x over sine x. And you'll notice our sine x can divide into each other, and you're left with cos x over 1, which is cos x. Okay, we've come to the end of the reduction formulas.